Welcome back. This is a very short conceptual development, so you'll probably have to find something to do after we finish. But we're going to be looking at motion when it does not accelerate. If I go 50 miles an hour and I don't get any faster and I stay at 50 miles an hour, after 1 hour I go 50 miles. So if I accelerate, it'll go higher than 50 miles. If I decelerate, which is also acceleration, just negative acceleration, I'll go less than 50 miles. But if I stay the same and do not change and do not accelerate, I will have covered equal distances in equal time. So look at the first picture here. I've got a 5-meter tabletop here, and a marble is rolling or a ball is rolling, and that's 1 meter apart. So after 1 second, here's where it was. 1 second later, it's here, and they've got it dotted so that you can see that it will be there in 1 second. It asks you, it says the ball rolls from the first position to the second position in 1 second. The two positions are 1 meter apart. So there's 5 meters total, and this is 1 meter apart. Okay. So the two positions are 1 meter apart. Sketch the ball at successive 1 second intervals all the way to the wall. Okay. So we're going to consider that it's not slowed down by the tabletop's friction or by wind friction or anything like that. So if this moves in 1 second 1 meter, I need to know what a meter is. There's another meter. Okay, so here is the ball after the next second. Okay, and here's the ball after the next second. And here's the ball after the next second. And then the ball kind of slams into the thing there at that second. So what's happening, it's covering the same amount of distance in the same amount of time if it's not accelerating. If it's accelerating, it's going to cover the same distance in smaller increments of time. If it's decelerating, it'll cover the same distance in longer increments of time. Okay. So the question here, did you draw the successive positions equally spaced, farther apart, or closer together? Okay. If it were farther apart, it means that it's covering more distance in the same time, because these are all showing the next 1 second, 1 second, 1 second. So these are the same, these are successive time intervals, and the distance interval, if I did it right, I tried to, would be the same also. Okay? If they were closer together, that means that they are covering less time, so it's be slowing down, and if it's moving farther apart, it's covering more ground, and so that would be speeding up. Okay, so I would just say evenly spaced. Okay, equal distance, I don't know how to say it, equal distance in equal time. Okay, the same 1 second it's going to cover 1 meter, and the next second it's going to cover 1 meter, etc. Okay. The ball reaches the wall with a speed of, okay, so what is its speed? It's traveling 1 meter in how long? 1 meter in how long? This is 1 second apart, so it's traveling 1 meter in 1 second, and that's what it's traveling here because it hasn't sped up. So it's traveling 1 meter per second. And how many seconds does it take to go to the wall? Well, here's 1, here's 2, here's 3, here's 4, and here's 5. So it takes 5 seconds for it to cover 5 meters if it's going 1 meter per second. That's just like going 50 miles an hour. It takes 1 hour to go 50 miles. 1 meter per second takes 5 seconds to go 5 meters. Same idea. Okay, we're almost done. This is it. This is the end. Table 1 shows that the sprinting speeds of some animals. Make whatever computations are necessary to complete the table. Okay. So I've got a cheetah. He goes 75 meters in 3 seconds. So remember your speed, this was from the other day, speed equals distance divided by time. Okay, so velocity is speed divided by time. Speed and velocity, remember velocity is speed in a certain direction, so that's, you can consider that synonymous. Okay, so I'm going to take 75. I'm going to divide by 3 because that's distance divided by time, and I get 25 meters per second. Okay, so we're going to do the same thing with this. Distance divided by time, so 160 divided by 10 is 16. Okay, so this is meters per second. So I'm going to have to do a compound unit, meters divided by seconds here, meters per second. The gazelle goes 1 kilometer and he's traveling 100 kilometers per hour. Okay, so what do? Speed is 100. So I've got 100 kilometers per hour equals, and what do we have? If I'm solving for time, how do I solve for time? I bring time up. Okay, you have to see this. I bring time up and I bring velocity down. So time is distance divided by velocity. Okay, so here is my velocity, 100 kilometers per hour, and my distance is 1 kilometer. Okay, so what is 1 kilometer divided by 100 kilometers per hour? So 1 divided by 100 would be 0.01 hours. Okay, so 1 divided by 100. And the last one, I have time and speed. So I want to solve for distance. So back up here, I have to bring time up to get it out of the way. So distance equals velocity times time. So velocity is 1 centimeter per second, and time is 30 seconds. Seconds will cancel with seconds on the bottom, leaving you centimeters, and my answer would be 30 centimeters. Okay, I hope you're thinking while we do these. I like helping you, but I don't want to do it for you. Okay, you always try to do your very best. All right, thank you. I'll see you in class.